Hello everyone, I'm here again to discuss to you the topic about tension force for General Physics 1. This is your teacher, Mr. Mark Anthony B. Laroya. Let us first define what tension is. Tension is the force exerted by the string to the object by pulling, or simply the force exerted by the string by pulling the object to prevent it from falling. So let's say we have a bar and then attached to the bar is a string, and the string is holding the object with a mass. Since the object has a mass, therefore it has weight. Weight is influenced by the pull of gravity, therefore the direction of the weight of the object is downward, while this string is exerting a force to hold the object. This force is what we call the tension or tension force. It is an upward force exerted by the string to prevent the object from falling down. At equilibrium, there is no motion. The object is hanging and the string is holding the object. Therefore, tension is equal to the weight of the object. Let us now discuss the free body diagram of our given scenario or situation. This is the free body diagram wherein it shows that the two forces are vertical forces, tension is upward, and the weight of the object is the force going down or downward. At equilibrium, the sum of all forces, or what we call the net force, is equal to zero. So we can say that the sum of all forces, which is equal to zero, is also equal to tension minus weight. Tension is positive because it is a force going upward, and negative for the weight because it is downward. Simplifying this equation, we have tension minus weight is equal to zero. And lastly, therefore, we can say that tension is equal to weight. Let us now solve a problem involving tension. Determine the tension force exerted by the string, which is also attached to the ceiling, to hold a 10 kg object and keep it hanging. So this is our illustration. The object has a mass of 10 kilograms, which is attached to a string, and the string is also attached to a ceiling. So the string is keeping or preventing the object from falling. This is our tension force or tension exerted by the string, and the weight is coming from the object. Using the same free body diagram, we have the tension that is going upward and our weight is going downward. The equation would be the sum of all forces or the net force is equal to zero. We only have vertical forces involved, the tension and the weight. Therefore, we can say that tension is equal to weight, like what we've discussed previously. Weight is the product of mass and the acceleration due to the pull of gravity, or that is g. So that means multiplying the mass of 10 kilograms to 9.8 meter per second squared, that is the acceleration due to the pull of gravity, we will have a weight equal to 98 newtons, which is also the value of the tension. Another problem: determine the mass of the hanging object if the force exerted by the string that holds the object is 50 newtons. So we have the object with a known mass, and this is our string that holds the object. The tension force, or the force exerted by the string to hold the object, is 50 newton. We can only solve for the mass if we're going to determine the value of weight. But since we consider that we are at equilibrium, using our free body diagram that shows that tension is the force going upward and the weight of the object is the force going downward, that means we have only two forces involved. We can say that the sum of all forces is equal to 0. Tension is equal to the weight. So that means the weight of the object is also equal to 50 newtons. Since weight is equal to mass times g, or the acceleration due to the pull of gravity, using this formula, we can derive the formula for the mass. Mass will be now equal to weight divided by the acceleration due to the pull of gravity, or g. So that is 50 newtons divided by 9.8 meter per second squared. We will arrive at a value of 5.10 kilograms. So the object has a mass of 5.10 kilograms. Thank you very much for watching and listening to this video, and I hope you learned something new about force, to be specific about tension. See you again next time, and God bless.